Greetings everyone, and welcome to this new series on multivariate linear regression. The last series on linear regression focused on univariate linear regression. Here, we will delve into the world of multiple linear regression, also known as multivariate linear regression, which, as the name suggests, deals with multiple explanatory variables for a dependent variable. The aim of multiple linear regression is the same in essence to that of simple linear regression, which is seeking to find the linear combination of predictors that correlate maximally with the outcome variable. This model is a bit more complicated than that of simple regression, but the basic principle remains the same as stated before. Hence, I highly recommend that you watch my videos on simple linear regression before watching this series. When we build a model with several predictors, the most important thing to bear in mind is to carefully handpick the predictor variables for a model, because the estimates of the regression coefficients depend upon the variables in the model and the order in which they are entered. One should not just enter hundreds of predictors just because they've measured them and expect the model to make sense. JASP will happily generate output based on any garbage that you decide to feed it. It will not judge you, but others will. Selecting predictors based on a sound theoretical rationale or well-conducted past research that has demonstrated their importance is extremely important. In this example, we have a dataset which provides factors which may influence album sales. The adverts column, as we can see here, represents the amount in thousands of pounds spent promoting the album before release. The sales column represents the sales in thousands of copies of each album in the week after the release. The airplay column represents how many times the songs from the album were played on a prominent national radio station in the week before its release. And the attract column represents how attractive people found the band's image on a scale from 1 to 10. First, we will check whether the predictor variables are linearly related to the response variable by running a correlation analysis. To do that, we will go into the regression drop-down menu, select correlation, select our response variable, which is sales, and add the other predictor variables. As we can see here, we can see that all the predictors are significantly positively correlated with the response variable, which is sales. Now to perform a multiple linear regression, we will click the regression drop-down option and select linear regression. Our basic assumptions that the response variable needs to be continuous, a linear relationship of the response variable to the predictors, that the residuals are uncorrelated with each other, and homoscedasticity or homogeneity of variances and normality of residuals remain the same. We will put the response variable sales into the dependent variables box and the adverts, airplay, and attract variables into the covariates box. That's it for this video. Thanks for watching, and I'll see you in the next video on input options.